Feature engineering is one of the core techniques that you can use to increase the chances of success in solving machine learning problems. As part of feature engineering, feature or representation learning is the technique that you can use to basically learn or calculate new features in your dataset. Having the right input feature is a critical prerequisite for training high-quality machine learning models, and it is often the case that existing input features are simply not enough to get those high-quality machine learning models. So feature or representation learning is used to transform sets of inputs into other new inputs that are potentially more useful in solving a given problem. So let's dive into the details of various approaches for feature learning. The first set of approaches in feature learning is the supervised approaches for feature learnings, where basically the new features are learned using data that has already been labeled. So an example of such a problem occurs in datasets that have multiple categorical features with high cardinality. In this case, classical approaches like, for example, one-hot encoding fail to produce results. Instead, what we can use is to use deep learning encoders to embed features into numerical vectors. Let me give you a practical example of that so you can better understand it. When you have to deal with a categorical feature, the problem is that if you do like simple embedding of the categories like 1, 2, 3, for example, then you already introduce bias into your data because you are implicitly kind of assuming that, for example, there is an order between the three categories, hence because you have used the numbers. So one approach there is to use what we call one-hot encoding, which actually means that you create a new column for each value of the category, and then you put in either 0 or 1, meaning that it is that category or it is not that category for each row of data. Now, imagine doing that for a column that is still categorical but has 3,000 distinct values. And then even more, imagine having 10 such columns in your data set. It is clearly that an approach like one-hot encoding cannot work because it would mean literally for you to add tens of thousands of new columns to your data. And that's where the supervised approach of feature learning proves to be extremely useful. Another example is with image classification, where the original form of the data may not be really suited for the classification task. And that's where supervised feature learning occurs, for example, more or less automatically within the hidden layers of a deep neural network. Another approach for feature learning is the unsupervised approach. With unsupervised feature learning, what you're trying to do is you're trying to learn new features without actually having input data that has been already labeled. And the typical form of feature learning is clustering, because if you think about it, when you split your data, your input data into clusters, basically what you do is you are assigning a cluster identifier to each row or to each case of your input data, which is nothing short of adding a new feature, which is the cluster identifier. So besides clustering, there are several types of machine learning algorithms that are used in feature learning, like, for example, principal component analysis, which is more like a statistical approach than a machine learning approach, independent component analysis, autoencoders, which use deep learning, matrix factorization, and some others. Don't worry about memorizing the list of these algorithms. What is important to remember here is that with the unsupervised approach of feature learning, you actually don't need existing labels on your input data, but you can learn new feature through some of these algorithms and then use those new features as inputs for your machine learning model training process.